Amy Pienta from ICPSR at the University of Michigan. ICPSR is a data archive that is within the Institute for Social Research. We are a social science data repository, and I am a research scientist there. I'm actually, as I look through the list of participants, I see a number of you that I recognize from other things around campus. So welcome to my talk today. The talk that I'm giving today is about what ICPSR is doing to begin to add capacity to add EEG data to our repository, because of course we are known for taking in and making available social science data and not EEG data. And so I do have a pilot project with others from the University of Michigan and elsewhere from MIDAS, so one of the PODS projects, to do some preliminary work to begin to understand how ICPSR would need to amend its tools and processes to begin to take EEG data in a more understandable way. So it sounded like a really good topic for this kind of seminar. So I'm a sociologist by training, so I fit in really well with the social science data repository. It also means that I don't know a whole lot about EEG data from the point of view of having collected it and worked with it. It's not something that I've done. I know much more about traditional social science data sets like surveys. And so waveform data like EEG data is new to me. And so I'm just going to start with the caveat that I'm really impressed when I go to talks and people talk outside their discipline and sound so knowledgeable and smart about those things that are outside of their discipline. I'm not sure I'm there yet with EEG data. So, so bear with me if you have very specific questions about this data format. I may not be able to answer them. In fact, that's a really good bet, but hopefully I can tell you about the tools and repository infrastructure and how we're orienting that to be able to take in EEG data, but the expertise for EEG data lies elsewhere. So with that, let me tell you a little bit about our project team. So my co-conspirator on this project is an EEG expert, Alif Isbel. Alif was a postdoc when at the University of Michigan when we began thinking about ways to begin to support EEG data better. And she was very excited about the idea of a place like ICPSR being the home for EEG data as opposed to other solutions that I'll talk more about in a little bit. So she has since ended her postdoc and taken a job at UC Merced in California. So she is now a junior faculty person there, but she, like I said, she is my co-conspirator. The co-PI on the PODS project is Bill Gehring, who is one of her senior faculty mentors in psychology here at the University of Michigan, and not directly involved with the PODS project, but hopefully down the road as we think about scaling up what we learned from the work we're doing in this project. Pam Davis-Keen, oops, I've spelled that wrong, no E at the end of Keen, will help Alif and I and Bill think about scaling this up with pursuing additional funding. From ICPSR end of things, there's two people who helped me. And so one is Erin Meyer, who's on the call today. She's our data project manager and keeping all of the activities going forward at Michigan and under Alif. And Tamara Kawasmi, sorry, excuse me. Tamara is a data curator at ICPSR who came to us from Wayne State, where she had worked with a lot of brain data. And so we've really used Tamara's expertise as well as we've gotten further into this project. So let me tell you a little bit about EEG data in case it's new to you. So what I'm talking about is not just EEG data, but EEG data that developmental scientists collect. So developmental scientists like Alif and Bill and Pam. But really, developmental scientists, of course, are interested in lots of outcomes that relate to brain function, and the electrochemical activity in the brain is something that is readily picked up and measured for probably the last 100 years by using sensors that are positioned around the brain, as you're seeing in this picture, to amplify and measure those electrochemical activities of the brain and measure them in waveform data. And so one of the things we know about EEG data is that it's really good at temporal resolution. So when you want to study things of the brain that have temporal change or variance to them, it is a really good method. Obviously, it's only one of many types of ways that we study and measure brain activity. PET scans, functional MRI, those are all also important, and some of those have greater spatial resolution that's really important to form and function of the brain compared to EEG, but EEG itself has a lot of advantages that I'll talk about. Again, from my vantage point. So in the realm of developmental science, there are several different ways that EEG data are used primarily. It's used in clinical research, especially in the pursuit of capturing and studying pediatric disorders. And so EEGs are really easy to use for populations that can't be stuck in an fMRI very easily, like children who wouldn't be able to tolerate that as much, because the EEG sensors can be worn by children, and also as they pursue other normal activities in their lives. So you can collect the data when somebody's still or in motion. And so you see a lot of clinical research being supported by the collection of EEG data. Same on some of the basic research questions that developmental scientists have as they look at the effects of things like what happens in school and how does that affect brain development or brain outcomes that we can study, like attention. And actually our pilot data set has very much that kind of bent to it. It's also really useful for studying whether the clinical or educational interventions that we have to affect things like how people perform in school, whether those things are efficacious or not. And of course, and its original use was for clinical applications for the detection of epilepsy and whatnot. And it's still used very strongly in that, as well as things like sleep and other clinical outcomes as well.
Hey, Amy, this is Brian.
Yeah.
Hi. Thanks.
Yeah. Hey,
so
Brian, ask your question.
I was looking at, later I'll show you something really cool on a device, but earlier in the week I was hearing that EEG, especially these newer, more portable devices, will have use in helping us understand how people are suffering from cognitive disorders, and and help us classify Alzheimer's patients and people with dementia and stuff like that. So I think that it's going to balance all these pediatric applications. What I'm seeing is that the techniques become more readily available, cheaper, and maybe even at home. I can show you something. We're likely going to see an explosion of those kinds of things. So I just not to interrupt, but I just thought that might be useful information.
Yeah, absolutely. Exactly. And I think as some of the algorithms we have to detect kinds of functional changes become more nuanced, I think that's where some of those applications are becoming much more used. And then again, a lot of populations have a hard time tolerating an fMRI. And so it is also
PET scanning. So for example, this one company, which I'll tell you about a little later, what they seem to be doing is, for some of this Alzheimer's diagnostic validation stuff, as an example, PET scanning, which is, expensive, somewhat invasive, you have to take a radionuclide and so on and so forth. There's access issues, disparity issues. This would be could be an alternative for stuff like that too, for confirmatory diagnosis for things like Alzheimer's disease and things like that. So I'll shut up now, but that's really one thing I learned earlier this week. I didn't know.
Yeah.
And
Yeah, that
also
is
traumatic
really cool.
brain injuries, concussions, this kind of stuff. So there's a lot of applications. Okay.
For sure. Thank you, Brian. I
You're
love
welcome.
that you're filling in some of the pieces.
Well, we're a team. We're
yeah,
friends,
no,
we're
please
a
help
team.
me.
Help each other out.
We are a team.
Yeah.
Yeah, and the equity issue is actually really interesting. And ICPSR has been spending a lot more time thinking about data equity issues. And one of the things that, like you were just saying, that I've learned along the way about EEG data is that there are a lot of researchers and teams around the country who can stand up and run an EEG. But they don't have access to an fMRI, right? And so they may be a neuroscientist with good questions and pursuing a research agenda, but the fMRI is out of reach for them. And so to the extent that science, obviously, at Michigan, we have both going on, but for smaller schools that don't necessarily have med schools and access to this kind of technology, we see a lot of data collections from scientists there are relying on EEG. So 100% what you said, Brian. The thing that's worrying to developmental scientists who are collecting EEG data is that it seems like each person is collecting it anew. That the EEG data that this particular discipline is collecting are particularly not findable, accessible, interoperable, and reusable, like we're hoping that all data becomes down the road. And so I'll talk a little bit about some of the reasons for that. A lot of the things that are true of EEG data and what has been limiting to sort of the advance of science in some of these areas comes from, again, these small research teams who have relatively small samples, access to EEG equipment, collecting data, using and developing their own protocols to do that, using equipment which varies from place to place, team to team, different equipment manufacturers, different settings of the equipment. All of those things have really meant that EEG researchers have not been able to have a standard product that they might contribute to a larger endeavor to put their individual data sets into something that would overcome some of the statistical power limitations that their particular study might have. It's also, like I said, harder to collect data from children. It's a good method for children compared to other parts of the life cycle. But at the same time, samples even of children tend to be pretty small in the developmental research area that Aleph and I are hoping to make some changes about how this gets done.
There are also, Amy,
yeah.
there are also more with children, there's more controls in terms of, HIPAA and stuff like that, It's a little harder to get a kid data.
Yes, and then harder to overcome some of the challenges when you have that of sharing those data in some kind of a collaborative, right?
Yeah, I think that's really true.
Some of the other challenges that worried Aleph when she came to ICPSR with this idea is that while there are other EEG repositories and places to potentially share EEG data, that the EEG data of developmental scientists was a little bit different from others in the sense that those repositories lacked infrastructure to adequately protect and share the other kinds of data that developmental scientists are so good at collecting. So the demographic information, the behavioral information, that detailed information about who people are and how they change over time and in the settings that we're studying them in. And most of the places like Open Neuro are good these days about taking in EEG data. But it's taking in EEG data without that broader context of the other components of the data that ICPSR is good at. And so the hope would be that we'd be able to do both the EEG data, but also the other data, so that if we think of the whole data system, we'd be able to ensure the confidentiality and privacy of the people who participate in these studies and give their valuable time with a broader group. And then there certainly are challenges of developmental scientists in it's still a pretty, even though there are places and standards for sharing EEG data, to get their data into this standardized data format. And so there may be something sort of particular about developmental scientists not being quite ready to embrace what I'll talk about in a minute, which is things like the BIDS EEG format. And so what we want to begin to lay out in our PODS project is setting out the requirements for a developmental EEG repository that's capable of addressing all of these issues. So we're looking to establish the requirements for an archive that would curate developmental EEG data securely, that it would assess the compatibility of existing data sets and these other parts of the data package that I just talked about, that it would incorporate analysis pipelines for standardizing that data and allow for secondary users down the line to be able to ask novel questions with these existing data. So our first aim in this project is to create and implement an infrastructure for archiving data. At least that's the big goal. And of course, in a pilot project, we're going to get so far down the road for creating and implementing infrastructure. It's not that big of a project. But borrowing on what we know and learn, and we have consultants from BIDS and connections to Open Neuro, along with our expertise at ICPSR with all those other kinds of data types that we know so much better, we think we can make some progress. So really what we'll be doing here for this aim of building infrastructure would be to at least establish the requirements for a user interface that's going to allow ICPSR to offer an easy way for this research community to give their data to ICPSR and for secondary users down the road to use it. And so one of the other aims besides writing requirements and how we actually get to the writing of requirements is that we're going to, we are actually in the process, we've taken in our first pilot data set and making progress with understanding how we have to align ICPSR with this data type and the standard that is out there. So hopefully you're convinced that what we're doing is going to be perhaps better than what others might do because of some of the unique capabilities of ICPSR. We think it will be among one of the first neuroscience data repositories that can offer the level of data security and curation that ICPSR is known for. It certainly would be new for ICPSR. We don't have anything like that. We have a very tabular data focused archive and some other data types, but not EEG data. And it will be among the first to offer some integration and systematic assessment of some of the different processing pipelines. And this I can talk much less about because that is ALIF's area of the project. The pilot data that we're bringing into ICPSR to begin understanding how we're going to adjust our tools is, it turns out we had others in mind, but the one we are using now and actually that we're about to release is the iListen study that ALIF herself collected. And it's a study of associations between things like socioeconomic adversity, classroom auditory environments, so there's actually auditory data actually in this data package, and the development of neural mechanisms that suppresses distraction among kindergartners. You can imagine kindergartners and their ability to do well in paying attention in the classroom is partly about all the noise stimulus that's heading towards them. So this particular data package is interesting because it has all the requirements of what we're hoping to work with. It has a wealth of parent survey data and behavioral data from the kids, as well as the EEG files. And so it's going to allow us to learn about what we need to do. So I'm going to turn and talk a little bit about the tools that we generally use at ICPSR, so you can see sort of what we're up against in terms of bringing in this square peg to our round hole, like my ambitious title said. So the first tool of any data set that's coming to ICPSR that anyone interfaces with is the Deposit Manager tool. And really, this is a tool mainly used by outside research teams and staff to give ICPSR their data package. So the depositor generally is using the tool. It's going to provide study information. That kind of information is used to build the citation for the study, the description of the project, what its scope is, its methodology, what its related bibliography are. So things that are going to be pretty common to EEG research for the most part. It also includes a file upload function to upload the files. So none of this is going to be too hard to amend to take EEG data in. So I just have two quick screenshots of what this tool looks like because it's the one tool that's easy to show to the outside world. So any user who's uploading data to ICPSR can kind of see all of their uploads. You can see here I've got 3 potential uploads going, either data sets that I've given to ICPSR or things that are in progress or things that ICPSR potentially turned away. When you dive into any one of these particular deposits and interface with the actual form, what you see are places where at the top where the files for the data package have been uploaded, and then lots of sections where we collect a lot of structured metadata or information about the study that, like I said, is used to build that citation for the data of the authority of who collected it and who should get credit. As well as other things about the scope, the methodology, the publication. So each of these plus signs rolls out into a lot of fields that are at this point very focused on social science data types and tabular data types. But this information that we collect in the form becomes the basis of all the other tools that the study goes through as it goes through the repository. So the information collected in that deposit form is then pushed into what our staff use, which is a metadata editor. And this is where we do our standardization work using our particular metadata standard, which is the Data Documentation Initiative, to edit the data so that it is one of the key parts of becoming findable, accessible, interoperable, and reusable. So our staff are using the metadata editor to, round out the information that the user has supplied, to apply controlled vocabularies, to make edits, enhancements, spelling corrections, looking at sort of other things in the data package to fill out the study description about the project. So that's the second tool, but the first sort of staff-specific tool that we have to think about when we think about bringing in EEG data. And then there are 2 more tools that are really heavily used in ICPSR, and I'll mention them because it becomes important to how I think we're going to approach EEG data. So the third tool is a data assessment tool. And this is a really fantastic tool that ICPSR has that really is used for SPSS files, which is the bulk of what we get added through our ingest system, through our deposit form. So when people give us data, they're often giving us data that are either SPSS or something that we can readily translate into SPSS. So this particular tool does a diagnostic of the files that were submitted and really forms a little bit of the basis of what our staff are going to do to standardize that data. So it's going to show what are the components of the data package, this SPSS, package of files that are missing, where there's labeling issues, components that might cause errors down the road for some of the other tools that we use. And also some information about identifiers that come particularly from open-ended responses that might be in that tabular file. So all of those things kind of get red light warnings, yellow, I think it's red, yellow, green, that gets fed to the staff and becomes the basis of work that we do subsequently with other tools. So after an editing and managing process, one of the, which is pretty manual at ICPSR, it's very manual. But the last tool that completes the curation workflow at ICPSR, again, to think about replicating what it does, is our conversion and documentation tool. And again, this is SPSS based, so we already had it as an SPSS file along the way. But at this point, it is an SPSS file that then produces all the different tabular statistical data packages that are popular with the push of a button. If there's 100 data files, SPSS data files in a package, it does it all at once. It also creates this DDI-based variable level metadata that's extracted from these input data files, which becomes the basis for code books and for online analysis capabilities, all the things that we're facilitating to make data fair. Gets done with this tool, and it's that DDI metadata actually generates a very beautiful standard codebook for that study that's been pushed through this final tool of ICPSR's ecosystem. So turning back to the question of the EEG data itself. As I mentioned, there are the BIDS EEG standard is certainly the agreed upon by the EEG community and neuroscience community. It's the standard with which the community has agreed data should be organized, described, and shared with one another. So the BIDS container that we know a lot about, because it's a standard that's been published itself, is very robust in and of itself. And so what ICPSR would need to do to be able to capture a data set that was already in the BIDS format would be to do very minimal changes to that deposit form, the metadata editor. Don't even need to ditch the SPSS files because these are not SPSS files, so those other tools, in order to be able to capture specific information about the EEG package. So pretty small changes to, we're thinking and hoping at this point to those first two tools that I talked about. And then really where we think we will focus our work, both our remaining work in the current pilot project, but then also the subsequent work that this becomes for ICPSR and future projects that we have, will be is really about engaging this developmental science community that collects EEG data to be able to bolster its own expertise to produce these BIDS EEG format files. So ICPSR's model, because we've done this for probably nearly 60 years, has been to tell the researcher with its SPSS file, don't worry, just give it to us, we know what to do with it. So that's kind of great for ICPSR. We have pretty robust ways of doing that and lowering the cost of doing that for the researcher and doing it well. But as we're thinking about a newer data type for us like EEG, do we want to recreate that? Do we want to become the experts in doing all that standardization work and organization work as we do for tabular data files? And I think the answer is maybe no. Again, because there's these agreed upon standards, agreed upon workflows for allowing the research teams themselves to do that kind of conversion. And so I think that's sort of stealing the short answer of this, is that we're putting a lot of emphasis into understanding how to take a typical data package that might, or a file structure and folder structure that a developmental EEG scientist would have stored their work in, and getting that to play nice with this BIDS EEG format. And then we're hoping that this then allows us to be able to allow the researcher to focus on the EEG part, giving it to ICPSR in a way that's more standardized, leveraging this BIDS EEG standard. And then as I said, putting the focus on training and outreach that helps the researchers to put their data into that format. It then means that we're making only minor changes to the repository infrastructure, and still allows us to focus on what we do well, which is this robust handling of all the other things in that package that the developmental scientist would have created, which includes our ability to handle restricted use data sets. And this becomes important, and I think I have that on the next slide to talk about. And so there are several things that came up already. It's been a year that the project was awarded, but of course with COVID, we're extending by 6 months. And so we're essentially halfway through what we want to be through at this point. But even in the 6 months that we've had, we've learned a lot of things about disclosure risk that comes from these developmental science data sets with the one study that we've ingested and curated so far from ALIF. So one was, we had intended to do one of Bill Gehring's EEG collections, Bill, Pam, Davis Keene. We were hoping that that was going to be our data set. It was a bigger data set. And the informed consent that was written for those data didn't allow for data sharing of those EEG data. And so we were faced with either reconsenting, asking them to reconsent their study participants to be able to follow through with sharing their data with ICPSR, or look for another study. And luckily we had our plan B, and that was ALIF's smaller study where her informed consent did address data sharing. So we went with that. But that's important, right? So a lot of the developmental scientists that we've been talking to are going to face this problem. And so we certainly are pursuing with the University of Michigan IRB some guidance to help developmental scientists avoid that problem going forward, and potentially have a route for doing reconsent so that data sharing is possible. The other thing that we found is that we actually had disagreements. So the curators, the curation team at ICPSR took in the package that ALIF put through our deposit manager, and then they began their work. And they came to the conclusion at the end that we would restrict the EEG file and make available the social and behavioral data, which was interesting to us because what we'd heard from ALIF along the way was waveform data of the brain is not very disclosive. So it was kind of curious that the end result was we would restrict the waveform data and make publicly available for download everything else. And as we went further with the curation team in this process, what we found is that the social and behavioral data and some of the metadata, like how the study was described, like where it was conducted, which was in the University of Michigan, clinics and whatnot, actually posed disclosure risk for the whole data package. And that by doing that, it became a particular concern from the curations team point of view that the waveform data, because it was a biologic form of data potentially, should not be shared. So yeah, I think what we've come, this is kind of crazy, right? So we're flipping the script. Yeah.
So, Amy, is this because some kind of patient identifiable signatures in the EEG scan that makes it identifiable? I mean, what's behind this?
It's actually just pretty benign. It's it's some of the indirect identifiers that are very detailed about these families, which have given us pause because we think that certainly a family could go in and pick out themselves. And when that happens, we get a little more cautious with the data. So there's very few people in this study, right? Like it's like a typical EEG study. It doesn't have a lot of people. So if, again, ICPSR is pretty agnostic when it comes to letting people use the data. If staff or families themselves that interacted with people in this study were to access the data through ICPSR, it's potentially identifiable. But then that says to me, you know what? just like Open Neuro makes all of the EEG data open to open for use because it's not disclosive, that's where we should do that as well, because that's where those data might be leveraged with other data that are in Open Neuro and other places. But what we should do is that if the user wants to access that rich, detailed information about the participants, about these kids and their families, and the school, some school data there, that's what we should restrict. And then EEG data used in combination with that would be done in one of our more restricted ways.
The EEG data is kind of a limited data set, and then which would be less restricted. And then if they needed other items with that, then there would be other controls. Yep. All right, thank you for that. That makes sense.
Yeah, and so like I said, so really, I think what our direction going forward with these incoming with these incoming EEG data sets, I'll just even broaden it to say EEG, no matter what discipline it's coming from, is to look at the metadata. So how much detail is provided in that, the other data components, the phenotypic data, right? As behavioral data, as well as the metadata about how the study is described. If the study is small scale in nature, it just makes our sensitivity higher with these other two criteria, what's in the data and how much information's there. Smaller numbers of participants sort of ratchets up our concern with the data set. At least that is our current model at ICPSR. And then, of course, that means that when any of those more revealing parts of the data collection are going to be used, we're going to restrict data access. So here's our remaining tangible study goals. So the data set that I just talked about is coming out from ICPSR. But these are sort of 4 requirements documents, reports, resource guides that we're also considering to be these endpoints of our study that we'll be working on over the next 6 months. So we will have some semblance from Alif herself, that is her shorthand about how developmental scientists can prepare their EEG data in the BIDS EEG standard. So like how to go from what they have to what it should look like. Second, again, from Alif, requirements for the ICPSR deposit manager tool about how we can expand the metadata that we're beginning to collect in that tool and then pushing onto the metadata editor for things that are more EEG specific. And then from Tamara and from Aaron, who've been working more on getting the data curated, guidelines for the curation of those data by our curation team at ICPSR, so that the next time we get a data system, we don't sort of data package, we don't sort of start with the same fundamental, misunderstanding of the files as we did this time, right? We can learn from the fact that the EEG data usually aren't that problematic to share openly, but if there's real risk in the rest of the data sets, that's where the restriction should probably be. And then finally, we are mostly the IT team at ICPSR is working with the rest of us to write requirements for ICPSR's data models so that we can begin to amend our data model to be able to fit things like the EEG data and the BIDS data format so that the data are truly fair. So like to give more parts, more support from the tools and workflows and processes at ICPSR to get closer to fair EEG data in a way that's as supported as possible by the repository. The other thing that we did actually before even starting the study was to ask people if this whole approach made sense. And so we have over 50 developmental EEG labs worldwide that signed on to our request to say, is this a necessary piece of infrastructure that you need to be able to share your data? And so this is an example of the teams that have that we've been in contact with, who've said that this is the critical missing piece to sharing their developmental EEG data at a much bigger scale. So we're excited that we'll be able to also marshal that community interest as we move forward. So our final things, of course, are all the work that I just talked about, getting that done. And then we have been actively exploring multiple grant mechanisms at NIH and NSF with plans to do writing over the next 6 to 12 months for a variety of deadlines that are coming up, so that we can take these requirement documents and put them into implementation at ICPSR, hopefully. So I think with that, I'm going to stop sharing my screen so I can see any questions that might have come up in the chat, but maybe they're not there. But feel free to both ask questions and put things in the chat.
Let me jump in for a sec, Amy. And then
yeah, go ahead, Brian.
Be quiet. I just want to show you something that I thought was kind of interesting. Let's see. So these are a couple websites that have popped up in my attention. This is called NeuroSteer. These guys are out of Israel. And, you know, what they've done is they've created this EEG band here. You know, so one thing I want to do is say that there is likely going to be some disruptive technologies, and I believe this is a disruptive technology that's going to revolutionize how we, you know, collect EEG data. This could be personal, you know, a person could buy this and track their own stuff. The musicians are, you know, as shown here, are really into this. You know,
hey, we have an arts archive at ICPSR, so perfect.
You can see that, you know, there's different data collection sites here. This here is another company here in I believe this is in Korea, iMedSync, where you can see, you know, kind of more classical, you know, hood coming on there, but really good software. You know, this is, you know, what I'm thinking is, you know, and these two companies are really focused in, you know, they have, you know, streamlined all the data collection apparatus. They made it cheaper, faster, better, all the good stuff. And, you know, I think what you're going to see is an explosion of this technology, you know, in, you know, for cognitive, you know, function analysis with dementia and Alzheimer's, like I was mentioning before. And obviously it's going to have an effect on what we're doing with the peds. So I think this is just going to get online, and it's just going to make this, it's positioning the technique to maybe explode, because it was way more experimental and kind of, you know, you had to be a real specialist. I think my sense is that somebody's going to pick this up. It's likely going to be the neurocognitive folks and I think for autism spectrum, classification, and you mentioned that, I think it's just going to be huge. So it's going to move way beyond epilepsy. That's all I'm saying.
Mm-hmm.
I would just mention,
you know, it's
that
happening, it's emerging right now. So I just want to bring that to everybody's attention. I think so. What I would say is your thing is timely, and you know, we should be looking for definitely partnerships, and be happy to work with you, you know, with our MISHAR unit and ICPSR, as well as, you know, the health system. You know, I can help with that. But anyway, that's all I had.
I'm seeing Vincent's talking about Calico and Google Brain. Yep. These are all really helpful comments.
I think that's
and
my point. Yeah.
Yeah.
That's on the longevity side. Yeah. Mm-hmm.
Did I hear somebody else? I thought I heard a voice, maybe with a question, or maybe it was just pointing me to the chat.
Any other questions for Amy?
Or Aaron, who's here.
Yeah. Oh, okay. Yeah. You know, I'm just wondering if, you know, ICPSR is an international resource. So, you know, my sense is, are you getting any information from, or any inquiries or interest, or is it too early to tell? I mean, I'm just wondering about that. And maybe connecting up with some of these. I was Googling around, and you had mentioned one, but, you know, there are some repositories of EEG data around on the web.
Sure. Yes, right. Which is why we've made our niche developmental science, right? Because it is sort of like the part of it that makes sense, because, you know, there's lots of places that can, you know, lots of even generic repositories can just take in BIDS format EEG data, right? It could be Figshare, it could be Dataverse, it can be any of the Dryad, right? Any of those actors. But for developmental science, where so much of the goodies lie in the other files that we are good at, we're hoping that that's what makes this compelling to NSF or to NIH as we expand what we're looking to do. So that's, you know, Pam's pretty convinced that it's not going to happen without a place like ICPSR being attached to it in a way that would really advance the science and developmental science.
Mm-hmm.
So,
yeah, you know, all this aging stuff is developmental science.
yes.
It fits in nicely. I mean, we often think
Yep.
we're more like kids, but it's more than
Right. I mean, it could be NIA. It doesn't have to be NICHD.
Right. Exactly, like NIA. You guys have done well with that.
Yeah, so it has a super advantage.
I would
All right,
suggest
well,
that
that's
you might
all
want to
that
look
I
at
had,
Hector
but-
Yee's work at Calico. He is actually one of the leaders in Google Brain and Calico in terms of doing advanced waveform analysis and predictive diagnostics off of it. He's a gentleman that I met about a year ago, and I saw a presentation from him a month or two ago. They're doing some incredible work, and they basically re-engineered several entire teams that were dedicated to machine learning and other medical aspects specifically to waveform analysis. Why this is the moment, I'm not sure, but there's a name for you that may be used.
Can you say
What
the
was
name
that,
again? So
Dan?
I heard the why, but not the who.
Yeah.
That'd be Hector Yee, Y-E-E. He's a software engineer, and I think he's a senior software engineer at Google AI Healthcare.
Okay.
That's very good. Thank you.
Yeah, thank you. Well, I'm not hearing anything. I
Yeah,
feel
I
like
think,
we've
he's
gotten to
not
the
done.
12:50 hour. This goes to 12:50, I believe.
Yeah, well, we're trying to become more sensitive to biological needs in Zoom.
Oh yeah, I've got some traffic jams in my schedule most days.
Oh my God. Well, this is super. Marcy, did you have anything you wanted to add at the end?
No, I'd just like to thank Amy for taking the time to talk today, and I would say that I hope to see everyone at next week's presentation.
Thanks a lot, guys.
Thanks for the opportunity. Have a
Yeah,
great
thanks,
afternoon.
Amy.